Hi everybody, Ms. Lee here. So today we're going to be talking about the Fundamental Theorem of Calculus number 3. This is an unofficial Fundamental Theorem of Calculus number 3. So this is something that I'm giving you as a resource so that when you're taking the exam, you can use this whenever you're put in a situation that is going to be described. Okay, so this one actually comes from the Fundamental Theorem of Calculus 2. So if you remember from Fundamental Theorem of Calculus 2, if you have the integral from, let's just say, a to x of f prime of t dt, what you would do is find an antiderivative of f prime of t. An antiderivative of f prime of t is going to be f of t because f prime is the derivative of f. So f of t is going to be an antiderivative of f prime of t. And then what you're going to do is evaluate this from a to x. And so what you get is f of x minus f of a. Okay, so just to put this in one line, just to reiterate, what we have here is the integral from a to x of f prime of t dt equals f of x minus f of a. And so what I'm going to do is I'm going to go ahead and add the f of a to the other side of the equation. I'm going to add f of a to the other side of the equation. And so I have f of a plus the integral from a to x of f prime of t dt. That equals f of x. Okay, so the f of a was added to the other side. Okay, what we have written here is essentially going to be the Fundamental Theorem of Calculus 3. So again, it kind of comes from the Fundamental Theorem of Calculus 2, but we want to write this as a separate formula because this is used more often, or very often, not more often. They're both used often. So what we're going to go ahead and write is the unofficial Fundamental Theorem of Calculus part 3. Okay, so we have not gone over part 1 yet. And what this theorem says is given a point, a comma f of a, and a derivative, or a function for rate of change. So rate of change means derivative. So some f prime of t, then we can write a function for f of x, where f of x equals f of a plus the integral from a to x of f prime of t dt, which is what we have written up there. Okay, so this is the Fundamental Theorem of Calculus part 3. So if you've ever been in my class before, you'll know that I put important things in pink clouds. This goes in a pink cloud, meaning it is very important and you will use it. Okay, so let's go ahead and do an example of this. So given the point 0, 4 on f of x, and f prime of x equals 5e to the x minus x, find f of x and f of 3. Okay, so finding f of x would just be plugging into this formula here. So we'll go ahead and do that. So basically, if it says the point is 0, 4, then that's your a and f of a. Okay, so let me go ahead and label that. So 0, 4, this is just a and f of a. So f of x then equals f of a, which is 4, plus the integral from 0 to x of f prime of t. Well, f prime of t is the derivative, and this is given here, so that would be 5e to the t minus t dt. Okay, so this is f of x. We're going to go ahead and simplify this because you can't leave an integral in your answer, of course. So we go ahead and we find the antiderivative of 5e to the t minus t. So we're going to find the antiderivative. And remember, when we're writing the antiderivative, you put it in a bracket and then you put the bounds at the end. So you put 0x like this at the end there. The antiderivative of 5e to the t is just 5e to the t, since the derivative of e to the t is e to the t. And the antiderivative of t is going to be t squared over 2. And so we have f of x equals 4 plus, and then we're going to plug in x and 0. So you have 5e to the x minus x squared over 2 minus, and then 5e to the 0 minus 0 squared over 2. As you know, 0 squared over 2 is 0. E to the 0 is 1, so this is just going to be minus 5. So f of x equals 4 plus 5e to the x minus x squared over 2 minus 5. F of 3, we can just plug 3 into here. We have 4 plus 5e to the third minus 3 squared over 2 minus 5. And as you know, for this class, you do not need to simplify, so we can just go ahead and leave it like that. So there you have it. That's the Fundamental Theorem of Calculus Part 3, which is unofficial, and an example of how to use it. Happy day!